and then welcome to this video. Now we are still on probability, and throughout our previous videos we will be able to look at the basis of probability, the addition rule, that of multiplication, that is AND or OR. Now we are now looking at random variables, and in this first video, as I did for the previous one, we take our time and then look at what the terms mean, so that when we begin we'll be able to understand what we are doing. So without much ado, let's take a look at what we have here. So when we talk of random variable, what does it mean? A random variable is simply a rule, right? So it is a rule or function that assigns a number to each possible outcome of a random experiment. Most of the times in our experiments, you see, we have outcomes. Apart from, let me say, a die, most of them aren't numbers. You see, so we call them outcomes just as they are. We can have a head and then a tail, right? But then we don't want to specify them with these heads and tails and then all that. We want to use numbers to represent them. We want to assign numbers to each possible outcomes, right? And then they are variables. They are variables that change. Hence, they are random variables, right? So a random variable is simply a rule or function that assigns numbers to each possible outcome, right? Okay. So then we'll look at some examples of these random variables. So let's start with the first one, tossing a coin, right? So when we toss a coin, we know our outcomes. Is that a head or a tail? You see, but using random variables, we don't want to refer to them as heads and then tails, but rather anytime we see a head, we assign it a value of 1, and anytime we see a tail, we also assign it a value of what? 0. You see, so hence we see a random variable x is defined as, this is x over here. We use capital letters to represent our variables. So the random variable x is defined by what? 1 if head and 0 if tail. You see, we call these 1 and 0 the sample points. So if you have x, which is our random variable, its elements being 0 or 1 can be represented with small x. So the element within the sample points, we use what? Small letters. So in some books, you would see random variable x, which has the element, we have xi, and then so xi, where this I here refers to the nth element. So for the first one, which is 1, the second one, which is 2. Hence, what we have here, we have x being a random variable. Then using the notation, we can say the first one we have can be called what? The first one we have can be called x1 and then x2. You see, yes, these are just notations. But the most important thing I want you to get over here is what? Our random variables. How we are representing them, these examples. Okay, now let's look at another example over here. So for this example, it's quite a coincidence that we have the output of what? Rolling a die. You see, so our outcomes are, we can see an image of a 1, 2, 3 up to 6, right? So random variable would define a rule for the output. We say random variable y. Okay, so we have our random variable y, which is going to give us 1 if 1. So for these ones, they just correspond, you see. So 1 if 1, 2 if 2, 3 if 3, and on and on and on, right? So that is the basis of random variable. Now, talking of the types of random variable, we have 2 types. We have a discrete random variable and then a continuous random variable. So we say discrete random variables take specific countable values They take discrete values, specific ones. So we have 1, 2, 3 in that order. But the continuous, they take within a range. They take within a range. So in our subsequent slide, we'll be looking at these examples. But get it that discrete take specific values. They do what? They take specific values. But the continuous aren't like that. They take within range. They take values within what? Ranges. Okay. So let's look at some examples of the discrete random variables. The first one being the number of heads a 3-coin tosses. So let me write the output here, then we can take a look at it. So when we are tossing a coin 3 times, we have 3 spaces. So you can either get, let's say, okay, so after working it out here, this is what we are going to get, what we see down here, right? So we want to assign random variables to them. I can get a head, and then a head. Is that the number of heads on a 3-coin toss? So you can get 3 heads, you see, and we can get 2 heads from this one here. You can get 2 heads. This here can also give us 2 heads. This gives us 1 head. This gives us 2 heads. Gives us 1 head. We have 1 head here, and then no head at all over here. You see. So our random variable here is discrete. So it's either 0, 1, 2, or 3. These are discrete what, or they are specific values. You see. Then our second example of a discrete random variable is the number of cars in a parking lot. If you go to a park, for instance, or a parking lot, and then you want to count the number of cars over there at a specific number of time. There are discrete values. Either there are 10 cars, or there are 15 cars, or there are 20 cars, or there is no car at all. You see, so these are examples of what we call the discrete random variables. All right. Okay. So let's look at continuous random variables. So for the continuous random variables, and a typical example is talking of time, temperature, height, weight, and all these. These take range of values. You see, so the time taken to complete a task, it will definitely be within a range of what values. Then another one being what? The height of a person. That is also definitely going to take a range of values, right? So we say these have infinite possible outcomes within a range. They are infinite. So infinite means we have so many. You see, so within a particular range, there are so many possible outcomes within the range. All right. Okay. So now that we know what these random variables are and then the types, which is discrete and continuous, why do we even need random variables? Why do we need random variables? So random variables, first of all, help us do what? Describe how random a data is. You see? So if you take a number and you're able to work with the random variables, you can tell how closely packed they are or how wide they are. You see, these same random variables also help us to calculate the probabilities of events. You see, and they also help us to analyze data. Examples, you can use random variables to calculate the average, the variance, and then what have you within a data. So as usual, I'll leave this practice question here so you also try. We have some toss a coin 3 times and then count the number of heads. I want you to identify the random variable, measure the time taken to drive to work, and then you have count the number of red cards within a shuffle. So you can look at these and then determine the random variables. In our next video, we'll continue with the random variables, but this time around we'll be going into detail. Stay tuned.